morning, children. In the previous class, we had done speed, velocity, acceleration, retardation, and all the terms we have done. Now, today we will be seeing another topic related to this motion. Children, can you tell me what is this? This is something which you have studied in previous classes. What is this called as? You remember it in maths? This is called as bar graph. You know. Now, what is graph? Graph is something which provides basic information. It is a convenient method to represent basic information. So this is your bar graph. Another graph which you will be studying in mathematics, or you must have studied, is this, which is called as line graph. Now here line graph, here you will have one quantity and you will be having another quantity here. It shows relationship between these two quantities. Such graphs are called as line graph. Now today we will see the graphical representation of motion. Now the first graph, you have studied about distance, you have studied about time, you have studied about speed. So we will be studying here first today distance time graph for uniform speed. Uniform speed, let us take a data. Here we are having the information. For 0 seconds, here it is time and here it is distance. For 0 seconds, 0 meter. 5 seconds, 10 meters. 10 seconds, 20 meters. 15 seconds, 30 meters. 20 seconds, 40 meters, and 25, that is 50. You can see this is uniform because you have 5 seconds difference in each, and here 10 meters difference in each. So this is uniform speed. Now I will be seeing how to draw the graph for this data or this information. This is 0. Here we can take this. Here we will be taking time in the x-axis. This is your x-axis and this is your y-axis. Okay. Here in the y-axis we will be taking distance. Now this graph will be showing relation between distance and time. Here is 0. Here you are having 5, 10, 15, 20, 25. Okay. A little bit more properly, let me represent it. We were not perfect about marking. You can do it. 5, 10, 15, 20, more, 25. Okay. So here we have marked seconds, time in seconds, and now distance 0. You get it here 10, 20, 30, 40, 50, here 60. So this is your distance. Now for 0 seconds, 0 meter. So this is your first point. Now second, 5 seconds, 10 meter. So this is your 10 meter and this is your 5 seconds. So your second point is here. And third point, 10 seconds and 20. So 20. You will be taking and marking it like this. With scale you do it. See, I am just marking it. This is our second point. This is our first point. You just do it with scale. Don't do it in this manner. Okay, this is our third point. So what do you need to do? You just need to join all these points. Join all these points. Join it with scale. So this is your first point, your second point, third point, fourth point. What type of graph did you get? You got a straight line graph. Straight line graph. So you can see here, distance time graph for uniform speed is always a straight line graph. Distance time graph for which type of graph? For uniform speed. For uniform speed, always you will have a straight line graph. Now, this is your first graph. Another graph. We will be seeing many graphs today. All the graphs. Now this is for non-uniform speed. Non-uniform, we can change this data. When we change this data, it will become here 10, 12, 20, 20, 29, 40. So this is non-uniform, you can see. So for such non-uniform, how it comes? It comes like a, this is here time in x-axis and distance. You have to just mark it in the similar way as we have done it for uniform speed. Similarly, you need to mark it here also the points. You'll get a curved graph. You'll never get a straight line graph. So for non-uniform speed, distance time graph is a curved graph. Okay. Now this is all about distance time graph. With distance time graph, yes, one more thing. From distance time graph, you can also calculate speed. You can calculate speed. What is the formula for calculating speed? For your data which was given for the previous one, it was 10, 20, 30, 40, 50. See, difference between these two, that is speed is equal to, you know, distance by time. So distance between these two is your 10 and between this time it is 5. So it is 2 meter per second. Got it? This way you can calculate the speed also. Now for the next one. Now we will see speed time graph. First you have seen distance time graph for the uniform speed and non-uniform speed. Now you will be seeing speed time graph. Speed time graph. In this, the relation will be between speed and time. And you will be having time in the x-axis whereas speed in the y-axis. Here time in the x-axis and speed in the y-axis. Okay. Now first, when we are having speed time graph, first case when we are having constant speed. Now what is constant speed? Constant speed means if a vehicle is moving, a car is moving suppose with a speed of 40 km per hour. Okay. Now it is continuously moving in 40 km per hour only. It is not changing its speed. It is fixed. It has started at 40 km, and it is continuously moving at 40 km. So that is constant speed. No retardation, no acceleration. Nothing is there in this. So that is your constant speed. So for constant speed, how are you going to take here for 5, 10, 15, 5, 10, 15 seconds, 20 seconds. You have here 10, 20, 30, here 40, here more. So for 5 it is here 40. Again for 10 it is 40, for 15 it is 40, for 20 it is 40. So in each case what it is coming? This is also a straight line. So the graph for speed time graph for constant speed is straight line. But what kind of straight line? Straight line which is parallel to what? X-axis. Parallel to x-axis. So speed time graph for constant speed is a straight line graph parallel to x-axis. Got it? Now for uniform acceleration. For uniform acceleration, in this case also you are having a straight line graph. This way. Here time and here the speed. So the graph in this way. Mark out that you know the graph properly because this is important to the point of view of examination. Here now for retardation if you do the same graph, retardation. From top to it will come to bottom. It will be a straight line but in downward direction. Here time and here distance. This type of graph you will get. Another for uniform acceleration again, but in that case your initial velocity is not zero. Then this is zero. This is initial velocity. Each time we are not, till now we are taking initial velocity 0. When the initial velocity is not 0, it has some initial velocity. So you will be having this type of straight line graph, but not from 0, from any of the initial velocity, whichever it is. Initial velocity is v, here speed. This is velocity time graph, that is speed time graph. Here time. So this is the graph. Now for non-uniform acceleration, okay, I'll draw these two graphs smaller so that we can adjust here only. See, this graph is in this manner. Uniform acceleration when the initial velocity, when it is u, it is not 0. Okay, when u is not 0, initial velocity is not 0. And the last one, when it is non-uniform acceleration. Non-uniform acceleration, it will be a curve graph. Okay, just like for non-uniform speed you had there in a curve graph, you did not have a straight line. Similarly for non-uniform acceleration, you will be having here a curve graph. So now, till now we have studied distance time graph and speed time graph. Distance time graph for uniform speed, that is straight line. For non-uniform speed, it is curved. Now speed time graph for constant speed is a straight line but parallel to x-axis. Then here speed time graph for, this is for constant speed, this is for constant speed, that is when the speed is fixed. This is for uniform acceleration, straight line from 0. Then retardation, you have it downward straight line, and when it is uniform acceleration but when u is not 0, this gives you straight line from u, and non-uniform acceleration you have a curved line. So this is all about the graphical representation of speed time graph as well as distance time graph. Now more about motion we will be studying in the next class. Thank you.